ठीक है. CSMA CD is there. Another term is the CSMA CA. So here still same. A means avoidance. Carrier sense multiple access collision detection and carrier sense multiple access collision avoidance. This we use into the wired. This we use into the wireless. Do you think in the wireless collision can happen? In the wireless, collision detection is not there. Only the collision avoidance into the wireless communication. Means if you have the AP here, that AP is transmitting a signal. PC is over the wire. We have the switch. PC. Here is CSMA CD collision detection over the wireless CSMA CA collision avoidance. Both are having the same mechanism and both we use into the Ethernet technology. CSMA C, this guy CSMA CA is integral part of CSMA. That means CSMA CA comes under the CSMA CD. Operation is same. Instead of having collision, we have the collision avoidance mechanism. अब सीरियस हो जाओ कि अब तुम्हारा नेटवर्किंग स्टार्ट हो. Now actual networking is going to start. ठीक है. First is ping. Ping is the tools or application. But what is the ping? Do you guys know? Can anyone try to explain what is the ping? Ping is the application or tools of IP upper layer protocol stack to check the network status, not to transfer the data. How would I come to know that you went to home? How? Or how would you come to know that I am going to class? I am coming to the class or not? So ping, it's a tool. Ping is a tool or application of IP tools or application to check the network status of IP upper layer protocol. Ping is a tool or application to check the network status of IP upper layer protocol stack. What is this? You can underline. We'll see in coming classes. What is the meaning of that? We'll see in coming. Clear? So, if I want to have a communication with you, I will call in or I will text a message. Then how would I come to know that person is, okay, let's suppose I want to check whether he is in Hyderabad or not. If I call, if I ping, let's suppose I do it with WhatsApp. In the WhatsApp, I will say, are you there in Hyderabad? He will reply that yes or no. If he doesn't, then I will not get information. Same thing with the ping. Ping. When you ping to any IP address or host name, if the IP address and host name is not replying, then I will consider that host name or IP address as a dead. He is no more into the network. Right? But if he replies or if PC or IP address is replied back to me, that means I will come to know that he is there into the network. Clear? So that is the use of the ping. Into the networking, the ping we use to check the network layer status of network device. Network device is router, switch, firewall, PCs. So network device are router, firewall, PCs. I want to check whether the device is reachable or not. You are here in Hyderabad. Let's suppose you have a customer that customer having some devices somewhere in US or somewhere in UK, somewhere in Bangalore, Pune. How will you come to know that the device is active or not? You will ping. From here, you will ping to that IP address. If that IP address is responding, that means the device is reachable. So let's suppose I want to check whether Google DNS is reachable or not. What I will do ping. Ping is the command that we use. After that, we need to put 8.8.8.8. The 8.8.8.8 is the Google DNS. Now, if you see here, I am getting the reply. That means destination is and is replying back to me. Right? What else we are here getting here? So, ping is used to check the below things. Network reachability, device status, IP reachability, both all are same actually. Network means your router firewall, device means your PCs, IP address. When you configure any IP address for the device, router or switch, that's what we use to. That's what we use ping to check the status. What else apart from that you are getting? If you see this packet flow, if you see this ping, in the ping, there are multiple things actually. How many packets? 4. 4, right? Okay. Packet sent 4. Packet received 4. Loss is 0. If you are sending same packet, if you are sending us some packet, if you are getting reply for all packets, that means there is no loss. And what else we have? Minimum, maximum, and average. This is the latency. Drop. And there is more term called jitter. So in the ping, you will get the information about drop, whether there is a drop in the packet or not, delay, how much time it will take for you from here to Sikandrabad, 1 hour. That is what. You will go there and you will come from the Hyderabad, sorry, Sikandrabad to here. 1 plus 1, 2 hours. That is the delay. So the delay is the round trip timer. RTT, round trip timer. Round trip. This total time taken by a packet from source to destination and from destination to source. That is the delay. Delay is not a single delay. Means it's not the delay of one direction. It's a direction. It's a delay of both direction. And to reach the Google DNS 8.8.8, the minimum delay is 15 seconds, maximum is 39, and average is 24 milliseconds. That means on the average of 24 milliseconds, I can reach to the DNS, Google DNS. A maximum is 39. That you can see here. I'm not saying anything. You can see here. Where is the maximum? This guy. Where is the minimum? This guy. So therefore, so it's calculating the average. Everything is there. I'm not saying anything. I'm not saying anything about it. It's there, but you have to know how to read the output. How to read the output. That's what you have to know into the networking. Don't have to do a very big thing. You have to read the output of that. You have to know how to read the output. Now you know how to read the output. In the ping, you will get the drop, delay. Drop means, let's suppose you are sending a 4 packet, you are getting a reply for 1 packet. That means 1 packet is dropped. If you calculate the percentage, it will come 80%. So there, if you see 0%, sorry, 0, loss is 0 percentage. If you're getting 1 packet drop, that means 80% loss. Sorry, 80%, 20% loss. And the delay. Apart from that, you will also get one more thing that is called jitter. Jitter is something. Let's suppose you are getting a response in 10 seconds. For some packet, you will get the response in 10 seconds. Immediately, you start getting 250 milliseconds. Then again 10 milliseconds. Then again 300 milliseconds. If you see this kind of behavior means where you are getting a proper response, immediately it's jumping to the 200 milliseconds. And coming back to the 10 milliseconds, again jumping back to the 250 milliseconds. That is the jitter into the network. So if you see something on the Google jitter example, you will see the same thing. You will see the continuous behavior. Then immediately you will see the spike into the delay. If you see this thing, visible, right? See, 1 millisecond, then immediately it's going to the 58 millisecond, 1 millisecond, 1 millisecond, 137 millisecond. If you see this kind of behavior means there is a jitter into the network, and it happens because of the bandwidth utilization. Bandwidth utilization means what? If you are having, okay, if from here to there, if I have the 1 GB pipe, 1 GB bandwidth, if I'm sending more than 1 GB, at that time, when the link is getting utilized, you will get the higher delay. If the link is free, immediately packet will get transmitted. Again, if more packet come to the link, it will get utilized and you will get the delay. Clear? So apart from the ping, clear? Apart from the ping, okay, with the help of the ping, you can also get the information ping uses ICMP protocol. You are pinging, but in the backend you have the protocol that is called ICMP protocol. Ping uses the ICMP protocol, and ICMP help us to provide the below information. What information? First is delay, second is drop, third is jitter. So in the ping, the first point is ping is a tools or application which we use to check the network layer status, IP upper layer status, or device status. Ping uses the ICMP protocol, and ICMP protocol helps us to provide the delay, load, delay, drop, and jitter. And I am saying ping is the tool or application that we use to check the network layer status. But if you disconnect all your network devices, sorry, if you disconnect all the network from your laptop, if you ping to an IP address that is called system loopback IP. (127.0.0.1). Try to do it. When you go to the home, disconnect all the network, Wi-Fi, wired, everything. And if you ping to this IP address, ping 127.0.0. You will get the reply. This IP address we use to check the NIC card status, whether NIC card is functioning properly or not. In my laptop, I am connected with the Wi-Fi. For Wi-Fi, I have the wireless NIC card. That wireless NIC card is working properly or not, I can use this command to check. That means if you disconnect all the things, all your network, wired and wireless, still you will get the ping. So the ping which is giving the information about the network layer status, IP upper layer status, or device status is not 100% true. Right? If I am not connected with any network, still I am getting the response. That means ping is not 100% true. Now, clear? Now if you see here, there are 4 packets. So that depends on the iOS or Windows. In Windows system, when you ping, by default, it generates the 4 packets. In Linux, it goes continuously. In router or network device, router or switch, if you ping, by default, it generates the 5 packets. So in that, the PC is generating 4 packets. So this 4 packet, in that we have 2 kind of requests. Come back to the initial stage. When I want to have a communication with this guy, I will WhatsApp, and that guy will reply. Then only 1 packet will get completed. In the 1 packet, I am sending a request and he is sending a reply. That means the 1 packet which I am sending, that is called echo request. The one he is replying, that is called echo reply. So in each packet, ICMP, so ping uses the ICMP protocol. Under the ICMP protocol, first is if this is the A and this is the B. If A wants to know the network layer status, IP upper layer status, or device status of B, the A will ping to, let's suppose 192.168.1.1. Then A will send the first echo request. Then B will reply with the echo reply. So in each packet, there are two things. One is echo request and another is echo reply. So if my PC, my Windows PC is sending a 4 packet, that means in backend there are 4 echo request and 4 echo reply. That is why it's a RTT, means round trip timer. The time taken from source to destination, one path, that is echo request, and time taken from destination to source, that is echo reply. That time is our delay. Clear? So this ping, when you ping, it sends the echo request, that another person will reply with the echo reply. Correct? Let's dig into more. Now, I am saying, okay, I am communicating with you guys in English, and you guys also replying in English. That means that is a common language. But how does we come to know that it's an echo request or echo reply? Because the devices, network devices, PC, they communicate in form of bit and byte, right? So how does we come to know that this is the echo request packet? I have to reply with the echo reply. Correct? So there is a, for echo request, type and code. For echo request, type is 8, code is 0, echo reply, type is 0, code is 0. When a PC B get this thing 8 and 0, that means it's an echo request. Now I have to reply with 0 and 0. If that 0 0 goes to the PCA, then PCA will understand it's the echo reply. You want to see this? Wireshark is the application that we use for the snipping purpose, means to capture the data. So right now I'm connected with the Wi-Fi. This is my active network, Wi-Fi. Okay. Okay, let's open the DNS3. I will take 2 PC. And we'll connect this PC. So don't focus on that, how to configure this thing, what is this, blah blah. We'll go everything in detail. So the point here is I want to show you the thing. So slowly we are going into the CCNA. So those are the cabling part, right? If you know, then fine, but you should know. But now onward, the IP address, and then after we have the Ethernet communication. Rules for the Ethernet communication. If I am communicating with you, there is a rule. In the same way, if a PC A wants to have a communication with PC, there is a rule defined there. It's not like that anyone can come and communicate with each other. So for each and everything, there is a rule. So let's do one thing. This is PC1. Router and router 2. So let's do one thing. Let's assign the IP address. 150. No worries about that. How we're getting, we'll discuss everything in detail. FA 0/0 IP address 192.168.1.1 No, sir. Let's come to the PC ping. Sorry. 150 interface FA 0/0 IP address 192.168.1.2 right? Now let's ping 192.168.1.1 because that side is 1.1 and this side is 1.2. Before pinging, let's capture the packet. Start capturing. I want to capture this interface as a 0/0 varchar. Okay, done. Stop. Okay. I'm pinging from 1.2. The 1.2 is the source. Destination is 1.1. What is the packet? बोलो सर वहां पे what is the packet? ICMP. That is the protocol behind ping. And what is sending? Echo request. Then 1.2 supposed to get what? Echo reply, na? If I am sending echo request, I will get the echo reply. So see the IP address. 1.2 is replying back to 1.1 is replying back to 1.2 ICMP protocol echo reply. Now I said if you open this packet ICMP, type is 0, type is a code is 0. That means it's a echo request. And what we have into the echo reply? Type 0 and code is 0. Getting? This is how PC identify whether it's a echo request or echo request. Echo request means type A, code 0. Echo reply means type 0, code 0. Clear? Then, if that is clear, then let's move further. So the next is actually rules of the internet communication. But before that, we need to understand small things. First is routing table. You don't want to write? My PC is there. How does my PC communicate with the internet? I am connected with the internet, but I am able to communicate Facebook.com, Cisco.com, Yahoo.com, Gmail.com, any website all over the world because of the routing table. In my PC, don't consider that only router has the routing table. Our PC is also having routing table. There is a command called route print. Go to the command prompt, give the command route print. If you give this command, you will say the routing table. This is the routing table of the PC. And in that, if you see, this is my IP address. If you give the command ipconfig, what is my IP address? 29.200. So this is my IP address and the gateway 29.1. Gateway is very important because gateway is the single exit point. If I want to go out of this room, I can go via this door. I cannot go anywhere. So for a single subnet, you will have a single gateway. So that is the gateway. Inside the gateway, I have this big house, big floor, multiple PCs, and all PC, if they want to go outside, they need to go via gateway. So right. This is my IP address 29.100 and the gateway. And what else we have? 00 and 00. Why do we have 00? Why? Because my router cannot contain lakhs of the route. Over the internet, we have lakhs of the route. 10 million, billion, not billion, 10 billion routes. 1 billion, billion. So if I take all the route,